Hello and welcome to another video, this time on mechanics, paper 2022 question 2, and it's a planes and forces question. Okay, so once again it seems they have no imagination because tan alpha is 3/4, which means sine alpha is 3/5 and cos alpha is 4/5. How am I getting that? Just draw a little triangle out, alpha there, you know that's opposite, you know that's adjacent, by Pythagoras you know that's 5, and therefore you get sine alpha is 3/5, cos alpha is 4/5. Okay, and we've got a small block, and we know, and I must admit, I don't like it. It's just out of a habit that I do this. I prefer to always have all forces coming out of the object rather than going into it. It's just a taste, personal taste, but it's just my taste. We're going to have the mass, which is 5g, I think, going down. We're going to have to resolve these parallel to the plane, I think. So I'll have that as alpha and perpendicular to the plane. So that's going to be alpha as well. You're going to have an R up here. Okay, is it rough? Yeah. So we want to think about which way it's going. Oh, we know R is 68.6. That's unusual. It would have told us R. We've got to find the magnitude of the frictional force acting on B and state the directional frictional force. So we need to consider the direction here. Okay, that's interesting. So we can work this kind of thing out. Firstly, let's point out that 68.6, start writing things down. The force acts in a vertical plane, which there's nothing I've missed in the question, is there? No. So we're going to have a 5g cos alpha acting down the slope. Yeah, that's certainly one thing. Sorry, 5g sine alpha. Let's get that right. We're going to have a 5g sine alpha there acting down the slope, which 5g times 3/5 is going to be 3g. So it's 3g acting down the slope. Now I don't know how strong this x is, and which way the friction's going is very much going to depend on the x. So let's try and find, let's try and find x. We're going to really need to, know that. So, okay, r equals 5g sine alpha plus x sine alpha. Sorry, I'm messing everything up today. It's early in the morning. R should equal 5g cos alpha. Yeah, always check your sines and coses. I do it a million times, I really do. Plus x sine alpha. Yeah, and now I know that's 68.6. I know cos alpha is 4/5, and so 4/5 times 5g is 4g. And then I've got x times 3/5. So by the look of it, that's enough for me to find x, because I can take away the 4g and then times by 5/3, and I'm going to get x equals, so let's quickly find out, 68.6, take away 4 times 9.8, and then multiply by 5 and divide by 3. Okay, I'm getting x equals 49 newtons, or 5g. Yeah. Now, if you compare x, in order to decide which way the friction's going, compare x cos alpha to, that's the force going up the slope, 5g sine alpha. 5g sine alpha is just 3g, and x cos alpha, well, that's actually 5g as well. So 5g times by 4/5, well, that's going to be equal to 4g. And so I now know the answer to part 2, that friction is going down the slope because the stronger force is going up the slope. Yeah, and what is the magnitude of that frictional force? Well, let's find out. We can say that, now is it in limiting equilibrium, this? It's held in equilibrium, yeah? And so what we can do is we can say, and actually I don't even need to, I can just see that F max must be the difference. It might not be at a maximum either, it's probably just friction, yeah? And I can just say that what F plus 5g sine alpha, well, that should be equal to x cos alpha. And so I get F plus 3g. Why did I write 3/g there? I'm finding it more and more difficult as I get older to talk and write maths at the same time without making mistakes. Okay, so I get 3g here, my x cos alpha is 4g, and therefore F equals g. So F equals 9.8 newtons, g, and the direction is down the plane. And that should do for that one. Okay. I'm just trying to decide. The mark scheme's really, oh yeah, down the plane. It does say down the plane. The mark scheme look really puzzling now. I'm sure you find that. Do you find that a lot? That you look at mark schemes and just think, what on earth are they going on about? Sometimes I feel like that as well. Okay, the horizontal force of magnitude x is now removed and b moves down the plane. So what have we got left? We've still got 5g. Cos and sine are the same. R is there. And if it's moving down the plane, friction is now going up the plane. Yeah. And if it's moving, then it will be a maximum. And we haven't found mu yet, have we? Oh, here we go. They're going to give us mu this time. Mu is 0.5. Okay, we've got to find the acceleration of b down the plane. So we've got 5g sine alpha, stronger force, minus f max, weaker force, equals the mass, which is 5, times by the acceleration. But we also know that r is going to be equal to 5g cos alpha. And so r is going to be equal to, as cos alpha is 4/5, 4g, and as f max is mu r, we're going to have 0.5 times 4g, which is 2g. And so this becomes 5g times sine alpha, which is 3g, because sine alpha is 3/5, minus 2g equals 5a. And so by the look of it, a is going to be equal to g over 5, and that should be the final answer. Yeah, it is as well. Just quickly checked, it's 1.96 newtons, which sounds like g over 5 to me. And that's it, that's that question. I thought that one was quite nice. Bit of a weird start. Have you noticed though in part B, it didn't really depend at all on part A. Apart from the prep work. Do the prep work, that's always important. Okay, hope that was useful. Best of luck in that mechanics paper. Come and see me if you're still stuck. Bye bye.